In this series of videos, we'll be going over how to set up a full VisRad example problem from the perspective of a first-time user. If you're a more advanced user and are interested in learning more about a specific feature, feel free to skim through the series playlist and jump ahead to a later video that interests you. Each video description will have a link to a VisRad workspace that corresponds to the starting point of that video. Now, for those of you who are brand new, VisRad is in a nutshell a powerful view factor code. It's used in major research laboratories across the world to model different types of target components and display how different laser beam arrangements would hit these target systems. You can think of VisRad as a type of CAD program that comes with different pre-configured laser beam and diagnostic port systems modeled off of different facilities across the world. These simulated laser systems, along with a range of different viewing and fidelity tools, allow users to set up and check different target laser arrangements for their high energy density physics experiments in a convenient and user-friendly way. In this series, we'll start out by getting familiar with the VisRad UI, and then after that, we'll begin a series of videos learning how to construct a target system. And then finally, we'll go over how to use VisRad's wide range of tools to ensure the target system is set up just right for your high energy laser experiment. Before we start building any target systems, we should make sure we know how to navigate some basic VisRad controls. So to do this, let's start out by opening a fresh workspace in VisRad. When VisRad first opens, you'll be asked to choose which laser facility you would like to load into. While you can always choose none and load into an empty arrangement, for our example, we'll be using the Omega laser facility at the University of Rochester Laboratory for Laser Energetics. After loading into the Omega chamber arrangement, you'll see a large blank space. This will be our target chamber housing our different modeled target components. This will be the main space for us to inspect and check how our target models are looking. To the lower left, we can see the list of lasers available for use at the Omega facility. We can turn on a couple right now and see them light up in our target viewer. For this introductory section, let's also add a couple target components. First, we'll add a sphere by going to Target, Add Object, and then choosing the sphere from the primitive types. This is the Object Parameters dialog. We'll get more into it in a future video, but for now, understand this is how we shape and position our target components. We can just accept all the default information and click OK, and we can see a sphere pop up at the center of our chamber. Notice how after adding the sphere, we can see the lasers terminate upon hitting the surface of the sphere, whereas before, they continuously shone through the chamber. This shows the most basic functionality of VisRad's target laser interaction modeling. Let's also go ahead and add a cube using the same method. We'll go to Target, Add Object, and this time we'll choose the box primitive type. This time though, we aren't going to center our cube at the center of the chamber. We'll go ahead and put the cube relative to the sphere a little ways off so it's not at the center. So we'll select the sphere for the reference coordinate system and then shift it down 4 millimeters down the y-axis. And we can see our little cube appear right there. Now let's go ahead and try out VisRad's navigation tools. In VisRad, there are three main types of navigation: rotation, zooming, and translation. These tools will move the current viewing position in different ways to navigate through your target chamber. The current viewing position can be seen to the lower right of VisRad's main window down here and can be displayed in Cartesian, cylindrical, and spherical coordinates. The first navigation tool we'll take a look at is the rotation tool. If you press and hold the mouse wheel while moving your mouse around, you can see the view in our target viewer rotate around the center of the target chamber. Now, the center of the target chamber is the default point of rotation, but this tool will rotate about whatever the last object selected was. So if we go ahead and select our cube and then once again use our mouse wheel movement, we can see the centroid of the cube is now the main point of rotation. We can also select a surface element to rotate around by holding down the Shift key and then clicking on a surface element of interest. So let's go ahead and pick this surface element right here. And now, if we hold down our mouse wheel and rotate, we rotate around the surface element instead of the centroid of the sphere. You should note that while rotating, vertical mouse movements will rotate about the horizontal of the picked object, like so. And then horizontal mouse movements will rotate about the vertical of the current picked object. Now we did all of this with the mouse wheel, but users can also use the rotation tool over to the right on the toolbar. And here we can see horizontal rotates about the vertical, and vertical rotates about the horizontal. Now let's go ahead and recenter our target viewer by using the second navigation tool, the translation tool. To use this with mouse shortcuts, you can just hold Shift and press the mouse wheel, and then move your mouse to translate your view left, right, up, or down. And much like with the rotation tool, you can choose to use the toolbar button instead of using the mouse shortcuts if you prefer. And finally, that brings us to our third navigation tool, the zoom tool. To use the zoom tool, you can just scroll your mouse wheel up and down, and you can see the target viewer zoom in and out. A good detail to note is that the point of zoom will always be at your mouse position. So if we put our mouse position over the pole of the sphere and zoom in, we're zooming in on the pole, and likewise we zoom out on the pole. Like our other two navigation tools, there is a toolbar button over to the right, this guy right here. This tool is a little different in that it doesn't use the mouse position. This tool will just do a general zoom in, zoom out based on the current viewing position. Now sometimes users might want to reset their current viewing position, and although you can use our three main navigation tools, there is a bit of a better way to do this. The first way to just recenter yourself is to pick the object you want to recenter at and hit C. And the view will adjust to that centroid of the picked object. Let's just turn this a little bit, click the sphere and hit C, and we shift over to the sphere. This is a fast way to switch between views of different target components. There are also 7 pre-saved orientations we can instantly switch to if we so want to. To see these in action, first, let's just go ahead and keep our axes visible for our sphere. And if we look to the lower left, you can see 7 buttons that correspond to 7 different pre-saved views. The first one will reset the view at an angle ajar so we can take a look at everything. And then the next 6 do classic directions: top from the z-axis, left from the x-axis, right from the y-axis, and then bottom from the negative z, right from the negative x, and left from the negative y. And much like all the other transformations, these will be based on the current picked object. So if we click the cube and we want to look at it from the z-axis, we can just click the z-axis here and everything in the view will shift for us. And with that, we have all the navigation tools we need to begin setting up our actual target system. I'll see you guys in the next video, where we'll begin setting up a classic hull realm typically used for a fusion experiment.